As you have seen, today's topic of discussion is effect of temperature on the solubility of solids. So we are continuing the water now. Already discussions were done on the chapter 1 and 2 many times. You keep revising as well, and also the mistakes that you have seen during the revision test that you try to overcome. And also today I will give you 5 distinguishing chemically as a PDF form. You download that, try to solve. Next day we can discuss the answers. Coming back to this, I think we ended the discussion based on the effect of temperature on gases in water. As we know that increasing temperature, the solubility of gas generally decreases. So now coming to the effect of temperature on solids. Maximum solids, if we talk about, their solubility increases with increasing temperature. But there are solids whose solubility decreases with increasing temperature, and sometimes increases and then decreases. So coming to all of those examples one by one. The first example, that is potassium nitrate and sodium nitrate. These substances solubility increases with increasing temperature. As I have said that maximum cases the solubility increases with increasing temperature. So these are just 2 examples. In those cases, or in these 2 salts cases, we find that as we keep on increasing the temperature, the continuous pouring of the amount of solute or dissolving the amount of solute in a given amount of solvent gradually becomes more. So if at suppose temperature 40 to 50 degrees centigrade, the amount of solute, potassium nitrate or potassium or sodium nitrate, these solutes are dissolving in water at a particular amount, at a particular temperature. If you keep increasing the temperature, more amount of solute will be dissolved in the given amount of the solvent. So these are the 2 examples where the solubility increases sharply with rise with temperature. Sodium chloride, which is a common salt whose solubility very slightly increases with increasing temperature. That means unlike potassium nitrate and sodium nitrate, their rising is very sharp. They increase sharply, their solubility increase sharply with increasing temperature. Whereas in case of sodium chloride, a very slight increase in solubility when we increase the temperature. Calcium sulfate is a very nice example whose solubility decreases with decreasing temperature. I hope you all are noting down the examples in the copy. You are sitting with the copy, so note down. As I am telling the examples, note down the examples. Calcium sulfate solubility decreases with increasing temperature. That means it is more soluble in cold water than that of hot water. We know one salt which is almost insoluble in cold water but soluble in hot water, that is lead to chloride. Calcium sulfate is the calcium sulfate's situation is just reverse of that. It is quite soluble, not very much. Actually, calcium sulfate generally we call it insoluble, but the some of the part of the solute is soluble in cold water, whereas in hot water its solubility is very less. Now we are coming to one salt whose solubility initially increases and then decreases, that is Glauber salt. Glauber salt is having formula Na2SO4.10H2 to the temperature approximately 32.38 degrees centigrade. Up to this temperature, increasing temperature, solubility increases, but as soon as this salt crosses this temperature range, and then if you start increasing its temperature, the solubility will start falling. That means solubility will decrease with increasing temperature. So we can observe a sharp break in its solubility curve. Solubility curve means it's a graphical representation where solubility and temperature, they are placed in the y and x axis, and then their solubilities are compared with each other. That is very much helpful to know how much or which salt will get crystallizes first than the other solute. It is very much needed for separation techniques. So in the solubility curve, as potassium nitrate, sodium nitrate, there will be sharp rise with temperature. NaCl will be a little rise with temperature, very slow increase. Calcium sulfate will have a fall in the graph, or there will be negative slope with temperature, and in case of sodium sulfate, there will be initially increasing and sharp break at 32.38 degrees centigrade, and then that will be decreasing in the temperature. The reason behind, as it states, it's anomalous solubility, and due to the presence of the water molecule initially, which that water of crystallization that affects the solubility, and then gradually as we are heating the solution, the water molecules, they start coming out from the crystal, and then accordingly the solubility keeps on changing. It is structure dependent, of course. So as the water molecules are coming out, as you know that water of crystallization means it's having a very important role in the structure of the molecule. So gradually the water molecule comes out and the solubility gets affected. So that was about the effect of temperature on the solubility. Now we are coming how the water molecule is getting attached with the substances, and we are getting these crystalline substances. As just now we are talking about water of crystallization. So this is the, I think, third part of the chapter, where we are going to talk about the salts and the water connections. That means how water is giving, water is playing an important role in a salts formula or in the salt structures. Now there are two types of salts based on the presence of water molecule in the salt. Water of crystallization is the number of water molecules which are joined with a particular substance with a very weak chemical bond and giving or providing a geometrical shape or crystalline shape to that particular substance is called water of crystallization. We know these waters are very important or very much important for deciding factor for the geometrical shape and even the colors also, and in the texture also. A very simple example is blue vitriol, which is having 5 water molecules, and if we take out those 5 water molecules, CuSO4.5H2O, 5 water molecule per molecule of copper sulfate. So if we take out that water molecule by heating the salt will get converted from crystalline to amorphous, and from color also will change from blue to white. Crystalline solid means the solids which are having a proper geometrical shape, and amorphous solid means they do not have a proper geometrical shape. So we can understand how much this water is important, or how much it's having an effect on the structure or the colors of a particular solid. So they become non-crystalline, they become amorphous when we are taking out the water molecule. But there are crystals as well which do not have water molecule, but then also they are in the crystalline form, like sodium chloride, magnesium chloride. They are also crystals, but they are anhydrous substances. So if you have to give example of hydrated substance which are crystal, that is copper sulfate, blue vitriol, green vitriol, hydrated copper sulfate also you can write, or hydrated ferrous sulfate also you can write. And if their question comes that give example of anhydrous substance which are crystalline, that can be sodium chloride, can be magnesium chloride. So we will be continuing our discussion with this next day, and today I am providing you that 5 distinguishing chemically. Try to solve that. See you in the next class. Take care and bye.